Okay, good evening. This is Professor David J. De Los Reyes. Okay, my topic for this evening will be a long video format discussion, and this is college algebra, and this will now be lesson number 32. Last night we finished lesson number 31. Lesson number 31 is actually solution of quadratic equation by factoring. So for tonight, we will be discussing the other solution of a quadratic equation. It seems it's just like the so-called a special case, because instead of by using factoring, we will be using the so-called square root method. Okay, let's proceed. The subject matter for tonight will be, it's August 14. This is college algebra, lesson number 32. Okay, we are running smooth. We are now on lesson number 32. We are past the so-called boring method, right? The concepts. Because it seems it's boring if we are hearing concepts, but when we apply it to solve a given example problem, it will not be boring. So we are running smooth. We are now on lesson number 32. And the title of lesson number 32 is Solving Quadratic Equations by Extracting Square Roots. The solution is just by using the so-called square root method. Okay, let's try to bring out the two possible cases on how to extract square root. Case number 1. If what comes out is x squared is equal to b, this is a quadratic equation, right? And with the given condition, if b is greater than 0, right? If we try to compute for the value of x, it will be the square root of b, right? But if b is greater than 0, it's not even 0, okay? What will come out will be x equal to a plus or minus the square root of b. There will be two values because the square root of a positive real number is actually a positive real number and a negative real number. So under case number 1, the value of x1 will be plus the square root of b, and x2 will be negative the square root of b, as long as we satisfy the condition b is greater than 0. There will be two values, and those values are termed to as real roots. Okay? That's case number 1. Case number 2. If we are still given x squared equal to b, but the value of b is less than 0, okay, there will be a problem. Because if the value of b is less than 0, meaning the value of the radicand or the sign of the radicand inside will be a negative thing. There will be a negative sign inside, right? So if there is a negative sign, it's impossible to take the square root of a number with a negative sign without the so-called introduction of the value I squared equal to minus 1. Because to simplify that negative square root inside the radicand, we must have to introduce I squared to be equal to minus 1. So under case number 2, if b is less than 0, the value of x1 will be an I, a positive I, the square root of b, and the second value will be by using the negative value, it will be x2 equal to negative I, the square root of b. And these two values here are termed to as the so-called imaginary roots, right? There is an I over here, so I represents imaginary, and we pass by imaginary numbers already, that is under complex number. So just in case you will be evaluating a radicand with a negative sign inside, to simplify that one, okay, use your knowledge of the so-called imaginary number. Okay, that will be case number 1 and number 2. As simple as that one. That is for lesson number 32. Okay, let's try to bring out example problem. Example number 1. solve the quadratic equation, the given quadratic equation, using the square root method. Using this method here. Will it either come out to be case number 1 or case number 2? It depends. Okay, let's try to bring out the solution. We rewrite the given right hand side, but we transpose this 4 to the right. So this will now be, right hand side will now be 79 minus 4. Right? Simplifying, this will be 3 times x plus 7 quantity square equal to 75. Okay, still the coefficient of the quadratic equation on the right is 3. So we bracket all the terms, then we will multiply all the terms by 1/3. So the right hand side, this will disappear. Right? What remains will be x plus 7 quantity square. Right hand side, 1/3 of 75, that will be 25. Okay? Expressing the right hand side to be a perfect square, because 25 is a perfect square. So this can be written as 5 quantity square. For the left hand side, it is still x plus 7 quantity square. Right hand side, this will be 5 square. Okay? So this will now be the resulting quadratic equation to introduce the so-called solution, square root method. Because to compute for x, we don't have to factor out. We will try to eliminate this power 2 here and this power 2 here. And to do that, we will bracket all the terms, then raise all the terms to the 1/2. Right? To eliminate these 2. Okay? So these 2 here, cancel with these. Left hand side, what remains will be x plus 7. Right hand side, okay, we will still take the square root of 5 squared. So again, these 2 here, cancel with these. So what remains on the right hand side will be, it's a positive number. The 1 inside is actually a plus, right? It is greater than 0. Okay? 5 is greater than 0. So what will come out will be either a plus or minus 5. Right? So the right hand side, since it is greater than 0, it falls under case number 1. It should be plus the square root of the given radical, negative the square root of the given radical. So actually, the right hand side will come out to be plus or minus 5. It will not just be only plus 5 because the square root of a positive number is either plus or minus. So there are actually 2 values for the right hand side. So x plus 7 will be plus or minus 5. Solving for x1, we use the plus first, right? So they should be 5. We use the plus. We transpose minus 7. x1 will be negative 2. Okay? By using the plus. And by using the minus, x2 now will be x with the subscript 2, meaning the second value of x, that will be negative 5 by using the negative side. We transpose 7 to the right, this will be minus 7. x2 now will be negative 12. Okay? To check the validity of this x1 and x2, we place these values here, back here. Okay? So what comes out should be a 79 equal to 79. So this will be true. That's one way of checking the validity of our answers, x1 equal to negative 2 and negative 12. The other check is by using the factoring method. If we try to, let's check the solution by using the factoring method. If we try to factor out instead of taking the square root. If we try to expand this one, what will come out for the expansion will be an x squared plus 14x plus 24 equal to 0. Okay, it's a quadratic equation, right? And to solve the solution of this, we will use the lesson number 31, that is the solution of a quadratic equation by using factoring. The possible factors of x will be x and x, and the possible factors of 24 will be 2 and 25. And if we try to check the middle term will be 2x plus 12x, which is 14x. So we are correct. This should be plus 2 and this should be plus 12 for the middle term to be plus 14x. So equating each factor to 0, that was lesson number 31, the solution of a quadratic equation by using factoring. x1 will be negative 2 and x2 is equal to negative 12. Same. Okay, hallelujah. We are able to check the validity of our answer by using the factoring solution that was lesson number 31. Okay, that's it. As easy as that one. Okay, example number 2. Solve by using square root method. We are given the quadratic equation x squared minus 10x plus 25 equal to 100. Oh, this is easy money, right? X squared minus 10x plus 25 equal to 100. Okay? If you don't know factoring, you're gone. Because the solution is by using this square root method. Actually, x squared minus 5x plus 25 is a binomial, the expansion of the binomial x minus 5 quantity square. Okay? That's why we pass by the so-called special products in factoring, right? You should know how to take the factor of a given quadratic equation. And luckily, the factored form of this is actually x minus 5 quantity square. Because if we try to expand this one, the square of x will be x squared. Middle term will be minus 5x times 2, that will be negative 10x. And the last part will be the square of negative 5. So this will be plus 25. Okay? So this quadratic equation can be factored out as simply x minus 5 quantity square. And for 100, it is a perfect square. It will be 10 square. Okay. And again, by bringing out the solution by using the square root method, we must have to eliminate this 2 here. And to eliminate this 2, we will raise both sides of the equation to the 1/2. So this 2 here cancel with this. What remains on the left will be x minus 5. Right hand side, this 2 here cancel with this. Okay? But the value of the radical is actually greater than 0. So the value should either be plus or minus whatever the square root, but the square root of 10. So the right hand side should be not just only a plus 10, it should be a plus or minus 10 because it is greater than 0. There should be 2 roots, right? So x1 now will be positive 15, okay, by using the plus sign. This is 10, we transpose this one to the right, so that will be 15. x2 will be by using the negative value, right? Then we transpose 5, so this will be negative 5. So the roots for the given quadratic equation will be x1 equal to 15 and x2 equal to negative 5. Again, let's try to check the validity of the answer. Instead of substituting to the given quadratic, we will try to factor out or bring out the solution by using factoring. Okay? X squared minus 10x plus 25 equal to 100. We put this to the left. X squared minus 10x minus 75 equal to 0. This is now the resulting quadratic equation, right? And try to bring out the solution of this by using factoring. The possible factors of x squared will be x and x. We cannot do anything about that. And the possible factors of 75, negative 75, it should be 15 and 5. But the sign of the middle term is negative. So the bigger factor of 75 should be negative and the smaller one should be plus. And if we try to check the middle term, minus 15x plus 5x is actually negative 10x. Okay? So we are correct for the 15 to be negative and this plus and this 5 here to be positive. And a negative 15 times 5 is actually negative 75. Middle term is negative 10x with these two signs here. So x1 now, by equating the first factor to 0, x1 will be 15 and x2 will be equal to negative 5. Same. Okay, that's it, guys. So for those of you who are taking up college algebra, this is for you guys. If you want to subscribe to my channel is at youtube.com/@proftvjdelos. If you want to share it, please click share. Okay, I will be telling this one. Try to watch my long video format discussion on college algebra. I am discussing concepts and I am presenting example problems based on the concepts so you will understand it. And that will be a good teaching. Okay, good evening from Los Angeles. This is Professor David J.